Good afternoon, everyone. My name is Juan Estepa. My teammates are Eric Santana and Shane Colon. We are presenting today fuel cell vehicles. How does it work and what is a fuel cell vehicle? A fuel cell is what you see here. It contains an anode, electrolyte, a cathode, and then a load where through electricity flows. Uh, in the first step, the hydrogen enters the anode, and then into the electrolyte, it's separated into ions and then electrons. The electrons then flow through the load, creating a current, which is the electricity. And then at the same time, the oxygen enters the cathode, combines with the ions and also with the electrons that come through the load, and then creates water. The water is the only waste material from the fuel cell, which is why fuel cells are a very green product. Some history. The beginnings of fuel cells go back to 1838, where William Grove created the Grove cell, which is the first fuel cell. Then in 1959, in the Alice Chalmers farm, a tractor is introduced as the first fuel cell vehicle. Then in the 60s, NASA used the fuel cell in its Apollo program, and it's part of running the electrical systems and some of the lunar modules. Then in the 70s, car manufacturers started begin researching fuel cell vehicles to try to commercialize them. In the 80s, the U.S. Navy actually used them for fuel cells in submarines. Some fun little facts. The fuel cell first became about from Humphrey Davy. He became the one that introduced the concept of fuel cells. Also, in 2007 is when they became to be sold commercially. Also, Honda released its first fuel cell vehicle in 2008. All right, some of the applications that fuel cells are used in nowadays are portable battery chargers, some generators, operating buses, cars, and forklifts. Now I'm going to introduce Eric Santana to continue the presentation.
The current design that these cars are under right now, they actually carry similar characteristics as your regular gas-powered or diesel-powered car, but they're also on a much simpler level. As you can see, the majority of it is built just solely on a fuel cell, battery, motor, and hydrogen tanks. And just like the equivalent, fuel cells are the gas or diesel for the modern day car that we all know. These are the five main parts. You have your power control, your actual electric motor, your battery, your fuel cell stacks, and your hydrogen tank. The power control unit, its main purpose is to convert DC to AC, and this power is what's used to actually power the motor that's driving the wheels. It has a safety feature. It keeps control of the power output for safe voltage. This is to prevent voltage spikes, which can cause surging in the automobile, which will completely shut it down or cause potential fires. You also have the electric motor. As I stated before, the electric motor is what drives the wheels. It also has a dual purpose where it acts as the generator. During braking, it has regenerator discs, so it is actually recharging and charging the drive battery at the same time. The drive battery, as you know, its sole purpose is to store energy. The way it stores energy is during the braking, like I mentioned earlier, it will store energy in order for, at the next point of acceleration, it actually creates the initial acceleration when you put your foot back on the accelerator. The fuel cell stack. Because an individual fuel cell cannot create enough power and voltage, it usually has less than 1 volt, they created a fuel cell stack. This stack is basically hundreds of fuel cells that are connected together in series to give the adequate performance necessary. The only limit between these is the size. So depending on if you're making a car or an SUV, your fuel stack could be larger or smaller. Finally, the hydrogen tanks. As I said before, this is basically the fuel for these cars. But just like anything else, you need to have the adequate amount of area, and With this, we're hoping that we'll be able to get more efficient miles per gallon in this case with the hydrogen tanks that I just mentioned. The other thing with these tanks is that for the sake of safety, they have multiple layers. For example, the same Toyota one has an initial plastic layer to hold the hydrogen. It is then covered in a carbon fiber layer for added strength, as well as a glass layer in order to protect in case of accident of any kind. The other thing is, just like I said before, its capacity will only be so great because depending on if you're making a car or an SUV, the amount of hydrogen you'll be able to have inside your tanks will be limited to that.
Okay, I'm going to be talking about the problems in designing hydrogen fuel cells. Hydrogen production is insufficient for our current needs. It is inefficient and it also has a large carbon footprint. Steam reformation is one of the biggest culprits of this. It actually creates a carbon footprint equivalent to gasoline cars and sometimes even larger. Then electrolysis has an energy efficiency of only 20 to 25% in a well-to-wheel analysis. What this means is from the initial energy put into the system to collect the hydrogen and get it to the actual car, it is losing 75% of it. The next major drawback is the expense to the consumer. These hydrogen fuel cell cars can cost anywhere from $50,000 to $60,000, which is almost twice as much as competitor hybrids and EV vehicles such as the Toyota Prius. The other big concern is fuel costs. Then there's also a lack of infrastructure. This is the largest problem for the fuel cell industry. There is a scarce availability of fuel stations, a lack of a distribution network, getting the hydrogen to and from production facilities to the fueling stations. And lastly, there's not enough production facilities to meet the demand of what they want and storage locations for the hydrogen. Now moving into future developments, we have platinum production, hydrogen production, and investing in the infrastructure. Platinum production. Platinum is used in hydrogen fuel cells as a catalyst to move hydrogen gas across the membrane, thus creating electric current. Current processes are inefficient in yielding large quantities, and they often get lost within the subatomic structure. New breakthroughs in nanotechnologies, specifically the nanoframes, allow for greater quantities to be produced. This calls for higher efficiency and lower costs for consumers. Hydrogen production is another big area to work towards. Solar power electrolysis is one way to remove that carbon footprint previously mentioned. Biomass gasification is another one where they take natural resources and use that to produce the hydrogen gas. And finally, microbial electrolysis cells are a new and upcoming technology that takes microorganisms to actually produce the hydrogen gas. Investing in the infrastructure is definitely the biggest strong point for the future of hydrogen fuel cells. California has already made plans to build 100 fueling stations by the year 2024. Countries such as Germany and Japan have already invested in fueling stations and creating the infrastructure needed to promote hydrogen fuel cell vehicles. And then if additional government aid were to be input, such as other states taking action similar to California, the U.S. would be on its way to implementing fuel cell vehicles.
In conclusion, fuel cell technology is the future, has a bright future in the alternative fuel source problem that we have. The continued investment in research and infrastructure are needed to be successful, as that is the biggest drawback. Hopefully, with the increase in research and production, we'll be able to make fuel cell technology and fuel cell vehicles the vehicle of the future. Thank you very much. That's our presentation.